Good day, students. Welcome to Bachelor of Education Senior Primary presentation for the examination of the year 2022. Natural Science Health 6. I'm your tutor, Christina Shikongo. Let's start. We will discuss some of the content of the study guide and the content of our module. And I'm not going to go in deep detail due to the content, but students are welcomed to contact me at my contact detail for more explanation. Otherwise, they can use different resources to prepare for the examination. I have decided to present some of the topics that I found challenging and troublesome when it comes to assignment and previous examination. Therefore, we'll start with bonding. Bonding is defined there. Students should know how to define bonding. And according to our modules, we are supposed to know that there are 3 different types of bonding. The 3 types of bonding are covalent bonding, ionic bonding, and metallic bonding. Students should be able to show how atoms are bonded in covalent, know the properties of covalent compounds, and be able to explain how covalent bonds are formed. For example, we know that covalent bond is formed between 2 atoms of nonmetals sharing electrons to obtain full outer shells. Covalent bonds include single bond, double bond, triple bonds, where 2, 4, and 6 electrons are shared between 2 atoms respectively. Then we have macromolecules, which are part of covalent bonds. Diamond and graphite, these are different forms of carbon. It's an element. They have different giant structure, but they are all containing carbon atom. Students are expected to know the structure of diamond and that of graphite and be able to explain the properties and the uses of diamond and graphite based on their structures. There we have the structure of diamond and graphite. Let's look at the properties. For diamond, each carbon atom in diamond is bonded to 4 other carbon atoms. These form a 3-dimensional network, and then it also forms a tetrahedral network that give diamond very hard strength. And then 4 electrons being shared means that no electrons are free, therefore diamond does not conduct electricity. Since there are no free electrons to conduct electricity, so diamond doesn't conduct electricity. Graphite, in graphite, each carbon atoms form 3 bonds with other carbon atoms. So there are 4 electrons on the outer shell of each carbon atom, so the 4th electron from each carbon atom is free to move. And that's what makes graphite conduct electricity, because of the free electrons. The carbon atom form layers of hexagonal rings, and then these layers are held together by weak forces between their layers. These weak forces allow the layers to slide over each other. That's what makes layers of graphite to slide, and therefore graphite is soft and slippery. Therefore it can be used as a lubricant. It's also used in pencil leads. The fact that graphite conducts electricity, it is used in electrodes in batteries for electrolysis. Since diamond is said to be a harder substance, it is therefore used for cutting and drilling. Then you move to bonding, ionic bonding. This is a bond formed between metals and nonmetals through transferring of electrons to obtain full outer shells. Students should take note that metal loses electrons and non-metal gains electrons. And the student also expected to try and know how to draw the transfer of electrons when it comes to ionic bonding. Metallic bonding, unlike covalent and ionic, with metallic bonding, students are not expected to draw the structure, but they should be able to identify it from all other structure that this is metallic bonding. Metallic bonding differ from other bonding in the fact that it's a single metal. These are just atoms of a single metal together. These atoms lose their outer shell electrons, and these electrons are not gained by any other atom. They are only surrounding the metal ions, and then there's force of attraction between the metal ions and the electrons on the sea of electrons. Now, since these electrons are freely to move, this is what gives metals different properties, like they are good conductor for electricity, they are malleable because the ions can slide over each other, and they're also good conductor of heat. The reason why metals are good conductor of heat is because there are forces of attraction holding these metal ions and electrons together. These forces require more heat to overcome them. Therefore, metals have high melting and boiling point. Then we move to the method of purification. In this case, I will not go in deep detail, but students are expected to consult me if they need some more explanation, and then they should also find more on the diagram that I use in the example of substances that can be separated by evaporation, crystallization, and simple distillation. Other methods of purifying also include fractional distillation and paper chromatograph. This information can be found in the study guide as well as in other chemistry books or physical science book, high school chemistry book or physical science books. The rate of the reaction is the next topic of our discussion. Students should be able to understand the correlation theory for them to be able to explain the rate of the reaction. We know there are some factors that affect the rate of the reaction, but for a reaction to take place, particles must have energy, and they must have enough energy to react. This amount of energy that is needed for them to react is called activation energy. So when particles react, they should collide, and then corrosion must be successful. Then the factors that affect the rate of the reactions are discussed in this slide, and then each factor is discussed. How does it affect the rate of the reaction? Temperature is one of the factors. So how does it affect? If you increase the temperature, the rate of the reaction will increase. But students are expected to explain how temperature affects the rate of the reaction. For example, if particles gain more energy, they will move more faster, collide more often, and that's lead to successful corrosion, and that's how the rate of the reaction is increased. Then another factor is the concentration. If you increase the concentration of the solution, the particles will react fast because they are more in one space. That will increase the rate of the reaction. We also have surface area. Surface area sometimes can also be said as particle size. Small particle size have more surface area, and larger particles have smaller surface area. So the larger the surface area, the more the contact between the reacting substances, the faster the reaction. Then we move on to measuring the rate of the reaction. The diagram shows the apparatus that can be used to measure the rate of the reaction. This might be a reaction where the gas is released. A gas syringe is used to correct and measure the volume of the gas. Then a stopwatch can be used. Then you can also measure the time taken for a certain amount of gas to be formed. Students should also be able to label the apparatus that are used. And there's also a graph next there which can be plotted after correcting data, which shows how the rate of the reaction goes on. At the first, the reaction was fastest. As time goes on, the reaction slowed down, and later on, when the graph becomes flat, it means that the reaction stopped. We also have another graph showing the rate of the reaction. These are two graphs. We have blue and red. The blue one is showing that this can be only a graph whereby we have higher temperature, high concentration, and small pieces. While the red one, this can be the case where you have lower temperature, lower concentration, and large pieces. The next topic is production of energy. Students should be able to name or discuss the ways in which heat can be produced. The energy that we are talking here is heat energy. Heat can be produced by burning of fuel. Heat can also be produced from nuclear fuels like radioactive isotope. When they are decaying, they are releasing energy. Heat can also be produced from burning of hydrogen, because hydrogen is not a fuel, it's different from other fuel. So those are ways in which heat can be produced. Then we also have energy chains, which include bond making and bond breaking. When a bond is being broken, energy must be taken in. Therefore, bond breaking is said to be endothermic, because endothermic is the taking in of energy. When new bonds are being formed, energy is released. Therefore, bond making is said to be exothermic. Then you should also be able to use ray diagram to state whether the reaction is exothermic or endothermic. This should be noted that from the energy diagram, the exothermic reaction, in the exothermic reaction, reactants are higher than the products. And in endothermic reaction, the reactants are lower than the products. This can be seen from the two graphs that we have. On the left-hand side, we have the exothermic reaction. So the reactants are high, and then the products are down. On the right-hand side, we have the endothermic reaction. The reactants are down, and the products are up. This also explains that if you are to calculate energy change, so for endothermic reaction, the H will be positive, and for exothermic reaction, the H delta H will be negative. The next topic is on types of oxide. We have 4 types of oxide. Basic oxide is formed by metal oxide. Acidic oxide is formed by non-metal oxide. Amphoteric oxide is formed by metal that are closer to the non-metal. They behave as metal and they also behave like non-metal. And this amphoteric oxide can behave as base and acid. Neutral oxides are oxide that doesn't either react with acid or base, for example, water or carbon monoxide. Acids and bases. Students are expected to read through the properties of acid and bases and know the difference and be able to define acid and bases in terms of hydrogen or proton donors and proton acceptors. Then you move to strong, weak acid and alkalis. It's clear that strong acid ionize completely and weak acid ionize partially. Strong base ionize completely, weak base ionize partially. The reaction of acids and bases are given there. Students should know the general equation so that they should be able to apply it to the question as they come. Then we should also know the preparation of salts. There are 2 ways of preparing salts. Okay, we can either prepare a soluble salt or insoluble salt. So the steps there are to prepare a soluble salt. The only thing that students need to note is that a soluble salt is prepared by acid reaction. The acid, all those 4 ways of reacting acid with other substances to form salt can be used to prepare soluble salt. But the other substance, if it's a base, it can be in a solid form or in a solution form. If the base is in a solution form, then titration is used. Otherwise, if you are preparing a soluble salt using a base which is in a solid form, the steps shown on the slide are the one to follow. Preparing an insoluble salt, this is a salt that is doesn't dissolve in water. The method is called precipitation. So the steps are there to follow, and there are not 2 ways. There are for a soluble salt there are 2 ways, either titration or using a solid. But in this case, it's only one method where you start with 2 soluble salt, you dissolve them in water, you mix them, precipitate is formed, you filter the precipitate, wash it with residue to just make sure that it's pure, wash it with distilled water, and then dry it. Then from there you have a pure insoluble salt. So we move to redox reaction. Redox stands for 2 terms, reduction and oxidation. Students are expected to be able to explain reduction and oxidation in 2 terms. In terms of oxygen gain, as well as in terms of oxygen gains, and in terms of electrons gains or loss. The student also be expected to be able to identify a reducing agent and oxidizing agent from a given reaction, or to be able to state whether a reaction is a reduction, it's a redox or not. Then we have an example of how to find out the reducing and oxidizing agent from a given reaction. Then the same case here, we have also another equation where we can also identify a reducing agent and an oxidizing agent. The next topic that we will cover is extraction of metal, but we'll only go look at the overview and then extraction of zinc. But we are supposed to know the extraction of aluminium, extraction of iron, extraction of copper, and the extraction of zinc. But due to time, I'll only highlight some important points. Students should also know the method of extracting most metals, and then you should know that the method of extracting this metal depends on the position of this metal on the reactivity series. The higher up the metal, the more reactive it is, and then the expensive method, and most of them that are up, they are extracted using electrolysis, while those that are less reactive, down hydrogen, they are extracted by heating them with carbon. We call it a reduction with carbon. Then you move to extraction of zinc. We need to know that zinc brand is a name for zinc ore. Zinc sulfide is a compound contained there. Two chemical reactions are involved. First, by heating zinc brand with air, then zinc oxide is formed. Secondly, now zinc oxide is reduced by heating it with carbon monoxide. And finally, we have zinc as a pure metal. With organic chemistry, we know that there are 4 families that you're supposed to know under organic chemistry: alkanes, alkenes, alcohol, and organic acid, which are also called alkanoic. For all those 4 families, we need to know the general formula. For example, for alkenes, the general formula is given CnH2n plus 2. Then we need to know the properties and the reaction of these families also. From the general formula, students should also be able to deduce the molecular formula of a given compound from that family. Reactions of alkanes there. We know alkanes, they have single bond throughout. Therefore, the only reaction that they can undergo is substitution reaction or combustion. They substitute with halogens. Halogens, we know they are group A7 elements. And then the product is a haloalkanes and hydrogen and the halides. Alkenes, the one that ends with ENE, they have a double bond between 2 carbon atoms. They are said to be unsaturated. For that reason, they are reactive. Therefore, alkenes can undergo hydrogenation, which is a process by which hydrogen is added to alkenes to form alkanes. Hydration, where you add water to alkenes and then they will form alcohol. Halogenation, where you add group 7 elements to alkane, then haloalkanes will be formed. Hydrohalogenation is a process of adding haloalkanes. This is a process of making haloalkanes by adding hydrogen halides. Hydrogen halides, for example, hydrogen fluoride, hydrogen chloride, a compound of hydrogen and group 7 elements. Then students should also know how to test for saturated and unsaturated hydrocarbons. Remember that saturated and unsaturated, these are alkanes and alkenes. Saturated are alkanes, unsaturated are alkene. How do you test, or how do you confirm that this is an alkane and this is alkene? So the test is there. Add few drops of brown. Please, the color of the substance must be indicated. It's either brown or orange, bromine water, to the hydrocarbon. If the color change, then that should be an alkene, the unsaturated. If the color did not change, if no color change at all, then this means that these are alkane because they are saturated, they don't react. Another substance that can be used for the test is potassium permanganate. You add few drops of potassium permanganate to the compound. If no color change, then this is saturated, which is the alkanes. If the color disappear, if the color change to colorless, This means that this is an unsaturated hydrocarbon. Then you have air pollution. Students are expected to know different pollutants of the air, how they are formed, their negative effect to the environment, to human health, as well as the way to control them. We have sulfur dioxide, which is formed by fossil fuel combustion, and it can cause acid rain. And we know the effect of acid rain. It can damage the buildings, it can corrode the statues, it can also damage plant leaves. Oxide of nitrogen can also cause acid rain, and it's normally produced from the car exhaust when oxygen and nitrogen reacts at a high pressure. The effect of rains are stated in that slide. We have come to the end of our presentation. Please feel free to contact me on my contact detail for any question. All the best in your study. God bless you. Thank you.